is represented by a symbol K. So it is represented as a spring. It consists of reference point. F is the applied force and X is the displacement in meter. So F is the applied force by your side and F suffix K is the opposing force due to the elasticity. Therefore, F suffix K is directly proportional to displacement. The constant of the proportionality which is represented by Fk equal to K into X. By Newton's law, it is given by applied force equivalent to opposing force equivalent to K into X. So now in this spring, suppose if it has the two displacement, x1 and x2, how will you write the equation? How will you write the mathematical model for this system? Suppose if it has a x1 and x2 two displacement like a previous slide, how will you represent the model? So it has only one displacement, x. Suppose if the spring has two displacement, x1 and x2, how will you write the mathematical model for the spring? So whether you can able to understand that spring consists of here only one displacement, x. If there are two displacements, x1 and x2, how will you write the mathematical model? Similar to the previous slide. See, the previous slide shows that Fb equal to d into d by dt into x1 minus x2. The dash part consists of two displacements, x1 and x2. So similar to this dash part, suppose the spring has x1 and x2 displacement, how will you write the mathematical model? So can you able to get the question?
K into x1 minus x2.
Okay, yes, right. So here you see that the spring consists of two displacements, x1 and x2. So F suffix K, that is opposing force due to the spring, is directly proportional to x1 minus x2, that is difference between the two displacements. So F equivalent to, that is applied force equivalent to opposing force equivalent to K into x1 minus x2. So you please take the paper and the pen. Please take the paper and the pen. You write these equations alone. So first you write the displacement x, or I can share the PPT. What can we do? Whether you write each and every equation pen and paper, or we shall directly enter into the problem.
Share the PPT.
Share the PPT. Share the PDF.
Share the PPT.
Okay, you no need to write the equation, right? You don't want to write the equation because next we are going to see the problem. Can you able to remember this equation?
Yes, sir.
Okay. So, first we have discussed the list of symbols. Next to one, mass. What is my mass? M into d square x by dt square. At least you please remember this so that next we are going to see the problem. You can remember this means we can easily solve the problem. So mass means F equivalent to Fm equivalent to m into d square x by dt square. It is a double derivative. Next, after the mass, dash part is represented by single derivative. That is F equivalent to Fb equivalent to b into dx by dt. So it is a single derivative. So first order derivative. So next one, spring, F equivalent to Fk equivalent to k into x. So I hope you understand this three expression. First one, mass means m into d square x by dt square. Next one, dash part b into dx by dt. Third one, spring is represented as k into x. So next is I'll enter into the problem. So these are the guidelines. They have given some guidelines how to determine the transfer function of the mechanical translation system. So to just read the 3 points. So mechanical translation system. Yeah, translation system, mechanical system will be given. You have to find out what is the output, Laplace transform of the output divided by Laplace transform of the input. That is, you have to calculate the transfer function. Okay, what is the objective? Yeah, system, a mechanical translation system will be given. Based on the system, you have to write that, you have to find out the transfer function, that is Laplace transform of the output divided by Laplace transform of the input. I hope you already studied the machines, electrical machines. Have you studied the electrical machines subject? Have you studied electrical machines?
No, sir.
No, sir.
No,
at least
sir.
electronic devices circuits, sir.
Going on, sir.
Going on.
This
Okay.
semester.
Only devices, sir.
Only device. Okay, no problem. See, whether it is an electrical system or electronic system, mechanical system, you have to find out three terms. Gain. Gain means output by input. For electrical system, efficiency, output by input. In control system, that output by input is given as Laplace transform of the output divided by Laplace transform of the input. You have to find out what is the output of the system, what is the input of the system. If you not understand this properly, still I give that clear explanation. Suppose if you are a human being, uh, uh, what is your input, what is the output? That is, you are taking the lecture, what lecture is going on, teaching lecture. The teacher was teaching, what knowledge you have get into you, what you have understand. In the examination, how you reproduce that. So the mark decides output by input. So in the lecture, the regular class hour, you are attending, you are gaining some knowledge. The examination point of view, you are appearing for the examination and giving some answers. So output by input, what is your output, what is the examination mark output, what is your input, what knowledge you have gathered, get into that. So that is called as output by input. Every system we have to calculate what is the output of the system, what is the input of the system. Okay. So the first point, it states that you have to first write the differential equation. So the main concept of the Laplace transform is it will convert the differential equation into algebraic equation. Differential equation is a complicated one. Algebraic equation is the simplest one. So the first point is a system will be given. We have to write the differential equation for the system. So how will you write the differential equation? You have to find out the node. So the node means, you have studied in the circuit theory. The node means the meeting point of the elements. The meeting point of the elements is called as node. So for a given system, find out the node. In the node, with respect to the node, write the differential equation. Okay. And then second point, the displacement will be given, x1, x2, x3. The displacements also will be given. You have to assign the displacement for each node. So the first derivative of the displacement velocity, the second derivative is already I shown it is a acceleration. So the first point is you have to write the differential equation for the given system. Then second point, find out the node. So the node means connecting elements, the meeting point of the elements. That is called as a node. Third one, you have to assign, you have to see what are all the displacement which is given. x1, x2, x3 are given. Third one, you have to draw the free body diagram for the system. For each mass element, you have to draw the free body diagram. After drawing the free body diagram, you have to find out what are the applied force, what are the opposing force. Calculate the applied force and opposing force. Then find out the row-wise order. That is, which are all the input force, which are all the output force. So please read these 3 points. If you are not understand, please tell me, because it is a 6-point procedure. So any doubt, tell me, or if you are finished means we can move to the next slide.
Yes, sir. We can move to the next slide, sir.
Okay, thank you. Next, after drawing the free body diagram, we have to write the one differential equation. That equation equating the sum of the applied force. That is, one side you have to write all the applied forces, another side you have to sum up all the opposing forces. Okay, this is the fourth point. So as per the Newton's law, applied force equal to opposing force. So applied force should be in a one side, that is left hand side. Opposing force equal to another side. You have to sum up all the applied force equal to the opposing force. Then after that fifth point, you have to take the Laplace transform of differential equation and convert them into algebraic equation. Then rearrange the S-domain equations and eliminate the unwanted variable. Then determine the output variable divided by input variable. So this is the objective of us to find out the transfer function. So remember that transfer function is nothing but very simple. What is the output of the system? What is the input of the system? So make a fraction output by input. That is called as transfer function. A system will be given. You have to find out the transfer function. What's my transfer function? Transfer function means output of the system divided by input of the system. So you see that note Laplace transform of x of t. The time domain is converted into domain. That is x of t. Laplace transform of x of t is capital X of s. Then how to take the Laplace transform of first order derivative dx by dt is represented by s into x of s. And know that these are all under the assumption with zero initial condition. And second one for double derivative, how will you take the Laplace transform? The Laplace transform of d square x by d square x of t by dt square is s square, small s square into capital X of small s. The s represents a complex variable, that is small s equal to j omega. So what is the meaning of this? Time domain variable is converted into frequency domain. You have any doubt? So these are all the simple Laplace transformation for the differential equation. Why we are using Laplace transform? It will make the simplification of the differential equation into algebraic equation. So differential equation is simplified as algebraic equation so that you can rearrange the order of the system so that you can easy to get the output of the system divided by the input of the system. Shall we move on to the next slide? Or you are finished means tell me. So any doubt in this Laplace transform? How you are transforming the differential into algebraic? How to take the Laplace transform? So first order and second order is showing it. Shall we enter into the problem? First problem.
Yes, sir.
Okay. So So, please take a pen and paper and you draw this diagram, and only you can able to understand the problem. First problem. Please take pen and paper and draw the diagram. I request each and everyone, otherwise we cannot practice the problem. Okay. Or otherwise we can move with the PPT itself. So what is your choice? So you please take the pen and paper, draw the diagram. That is figure 1. Draw the diagram, figure 1. So have you finished this?
No, sir. Wait.
Okay, okay. So you please draw this diagram. So what is my M? M is nothing but a mass, and B represents the dashpot. K represents the spring. So what is the X? Small x represents it is a displacement. So I request each and everyone, please take the pen and paper. If you understand the one problem, how to solve this problem, it is easy to solve any kind of problem. So question is, write the differential equation governing the mechanical system and determine the transfer function. So what is the transfer function? What is the output of the system and what is the input of the system? So M represents mass, it is mass weight, moving object. K represents the spring to represent the elasticity, and B represents the dashpot represents the friction.
Finish, sir.
So all of you have finished it? Huh?
Yes, sir.
So if you see, if you have any doubt or problem means immediately put the message in the chat box so that everyone can see that difficulty. So have you drawn this diagram? What is the M? M is nothing but mass. B is dash spot to represent the friction. K is nothing but a spring to represent elasticity. So now what is the first step means you have to consider the mass, only the mass, because the mass is the moving object, right? So M is the moving object. So we are going to see only the what are all the elements connected with the moving object. So M1, so B1 represents the dash spot 1 and B2 represents the dash spot 2. So if you note that what is the another one, F of T. F of T is nothing but the applied force. Okay, F of T is the applied force, that is I am applying the force. So opposing force means dash spot and the spring and the mass weight M. These are all the opposing forces. Okay, you understand the meaning for this? F of T, small f of T is the I am applying the force to move the mass M1 and M2. What are the opposing forces? Dash spot, spring, and M. These are all the opposing forces. So now what is the first step? You have to consider only M1 and analyze the M1. Next M2, analyze the M2. Okay, can we move to the next slide?
Yes, sir. Yes, sir.
So it shows the solution, right? So what is the input? Applied force. I am applying the force. If please note down, F of T is the applied force. That is input. I am applying it. And what is the output? Yes, how much distance it is moved. M1 and M2 is moved. So small x is the output. So the Laplace transform of the input and the Laplace transform of x and x1, because there are two, x as well as x1. There are two. So hence the required transfer function is x divided by f of s. So if you have any doubt in this slide, please tell me. Transfer function. We have to find out the transfer function. Transfer function means output by input. Input is the applied force. Output is the x. How much distance the M1 and M2 is moved. So therefore, it is given by x is the output, f of t is the input. Hello.
So like
So
input
please
is
note.
of force and output is in terms of displacement. Like both I have different.
Yes, sir.
Then how we can find the transfer function?
Input is the force. That is output by input. Yes, exactly. Because we are converting it, we are writing the differential equation of the system. F is in input force in Newton. Output is x is in meter. So here the transfer function is, which is a normalized one. That is without considering any initial condition. We are normalizing, writing the differential equation of the system, not considering the unit. How much distance moved for the given input force? Okay.
Okay, sir.
How much distance is moved for the given input force? So you see that already we discussed. It is a node. Only we have to concentrate mass. You have to consider mass. What are the connecting elements to the each mass? So therefore, it is specified as two. There are two masses, M1 and M2. First, analyze the M1, then analyze the M2. What are all connecting elements? Write the equation, then join the equation. Find out the overall transfer function should be what is the output of the overall system, what is the input of the overall system. So x is the output. Here there are two x's, x and x1, but the small x, that is the final output. Okay, you have to consider which one is the final output. You should not take x1 here. I hope you understand. X1 is the initial, that is first stage. What is the final stage? X is the final. You see from this diagram, x1 is the first, x is the final displacement settled movement of the system is final settled down movement. So small x is the final output divided by input is applied force. So hence the required transfer function is x of s divided by f of s. You should not specify the time domain because we have taken the Laplace transform. So please remember that if you put a t and put a Laplace transform means it is wrong. Laplace transform means converting the time domain into frequency domain. If the small s represents s is equal to j omega, complex variable. So shall we move to the next slide, or you finish this, or any doubt in this?
So can you repeat like what Laplace transform does?
Laplace transform, see, Laplace transform converts the time domain into frequency domain. It converts the differential equation into algebraic equations. So that is, the t term is converted into s term. That the small s equivalent to j omega. Omega is nothing but a frequency. So the time domain is converted into complex frequency variable. So the Laplace transform helps to convert that time domain response into frequency domain response. It will convert the differential equation into algebraic equation so that you can easily to find out the output of the system divided by the input of the system. So here another point is only we have to consider the m mass because that is the object we are going to move. So mass m consists of two forces. What is the input force? That is what force I am applying. What is the force opposing to me? I am applying force. What is the force against to me? We have to calculate these two forces as per Newton's law. Applied force equal to opposing forces. So there are two masses m1 and m2. First analyze the m1, then analyze the m2. So any doubt on this? Shall we move on to the next slide?
Yes, sir.
Okay, see, just I go to the problem again. So M1, in M1, what are all the connecting elements with M1? M1 consists of what are the connecting elements with the M1? So just you put in the chat box, right? M1, you take M1 alone, what are the connecting elements? What are all the symbols connecting with M1?
Spring and M2.
Spring K1. Say you don't consider M2. First M1, only M1, K1 is connecting, dashpot B is connected, and K is connected. So once again repeating, this is the mistake. But anyway, I am very happy. You have first to find out the mistake. M2 is not directly connected to M1, right? So M2 is not directly connected to M1. So M1, what are all the elements connected with M1? K1 is connected, B is connected, K is connected, and with the additional to that B1 and X1. So how many elements? There are 5 elements with M1. So I once again repeating, you take M1 alone. What are all the quantity elements related to M1? K1, B, K. And then small x1, another one is B1. So there are how much? 5 elements. So shall we proceed the problem? Any doubt with this? How there are 5 elements connected with M1?
Sir, can you tell the equation of the free body diagram of the M1, sir?
Yes. See, I hope you understand this free body diagram of the M1. So how many elements are related to this? 5 elements. So X1 is the displacement. So you please draw this diagram M1. There are 5 forces. That is opposing forces 5. Applied force is 1. Applied force is small x1. That is applied force. It will move the displacement distance is x1. How much of opposing forces? There are 5 opposing forces. Fm1, Fb1, and Fk1 and Fk. So any doubt on this? You please draw this diagram M1.
Displacement of
displacement. It is
of M1 will be X, no, sir?
X1.
How, sir?
See, you go to the diagram.
Yes,
X1.
sir.
X1 is right. M1 nearer to the displacement is X1. For M2, it is small x.
Okay.
Any doubt? See, that's one day. You draw this diagram, then only the next coming section, with this diagram only you can relate how it is connected. So whether you drawn this diagram, figure 1, all of you?
Yes, sir.
Yes,
See,
sir.
I request please draw this diagram. One problem, if you understand, means next thing you can easily understand. Okay. So I go to the free body diagram. Shall I move to the free body diagram?
Yes, sir.
Yes, sir.
See, free body diagram M1. M1, you note on this. The Fm1, Fb1, Fb, Fk1, Fk. These are all opposing forces. X1 is the applied force. That is, it is a displacement due to the applied force. Just note down M1. Only we are considering M1. Next, you are going to write for M2. So M2, how much opposing forces? M2. What? How many number of opposing forces in M2 if you consider only M2? So have you drawn this diagram?
Three.
You finished this. M1 you finished. Everyone copied this diagram. Shall we move to the diagram figure 1?
Yes, sir. Yes, sir.
M2. What are all the connecting elements with M2? That is opposing forces.
B2.
B2. Okay. B2.
No.
B2. Okay. B2.
K.
K.
Another one.
B. B. XB.
X and
X and B, sir.
X and B, sir.
B. B X B2 X and F is the input force. Okay. So 4 are opposing forces. That is 5 opposing forces. F is the input force. So for the first free body diagram, so this is the differential equation. You just write down this equation. So there are 5 forces. First free body diagram. So for this diagram M1, you have to write the differential equation. F M1 equal to M1 into d square x1 by dt square. You write this equation. Please write this equation. Then only you can know how to solve the problem. So with figure 1 as a reference. The figure 1 as a reference, you write this equation and cross with that equation. Whether you are writing exact and correct differential equation for the system. Because from this section onwards, we are starting the mathematical core component of the side. So write this 5 opposing forces in the M1. Each opposing force write the mathematical model. Then, as per Newton's law, opposing force equivalent to applied force. Add all opposing forces, add all opposing applied forces, then equate it and give the final equation. So M represents the mass, V represents the spot, and K represents the spring. M represents the weight of object, V represents the friction, K represents the elasticity. So can you write? Can you able to understand what is the meaning of how they are writing this equation and why we are summing up the forces? Any doubt on this? So any doubt on this slide? So keep the figure 1 as a reference. Keep the figure 1, and we are with respect to only M1. What are all the opposing forces? What are all the applied forces? We are writing a differential equation for applied as well as opposing. Then equate the two forces and give the final expression. You cross check with this equation with the figure 1 whether you are correctly writing the differential equation. If you are not understand, please don't hesitate to raise the question. Whatever the question, please raise the question. Okay, maybe that question have some other students also have the same doubt. So, we move on to the M2.
Yes, sir, we can.
M2. So this is the slide which takes the Laplace transform. You are given the previous equation, right? M1 into d square x1 by dt square. So for this equation, you take the Laplace transform. So taking the Laplace transform for the above equation, zero initial condition. So already I given how to take the Laplace transform. If it is a without a derivative, it is a first order derivative. If it is a second order derivative, how to take the Laplace transform? You yourself write the Laplace transform for the previous differential equation and cross check with this answer whether it can able to write the Laplace transform for the differential equation. So with the previous equation m1, therefore d square x1 by dt square plus b1 dx1 by dt. For this equation, take the Laplace transform and rearrange the terms and write in terms of x1. So it's a simple step. You take m1, what are the applied force, what are the opposing force, write the differential equation, add the forces, that is add the differential equation, then take the Laplace transform for that equation. So why we are taking x1 as a reference? Because for m1, x1 is the displacement, how much distance is moved. So it is a mechanical object, m is a mechanical object. I have applied a force, how much distance it is moved, it is given as x1. So for that, we are representing the final expression as in terms of x1. x1 equivalent to what is the element of that m1 mass. So you please write the Laplace transform, take the Laplace transform for the previous differential equation and rearrange the term. So can I able to get this answer? You cross this. Whether there is any mistake in this or you are facing any difficulty, how to take the Laplace transform, how to rearrange the terms. So shall I move on to the next slide?
Sir, can you please check the chat box, sir?
Okay. Okay. So next time, actually, this is the notes. This only I. So okay, up to this, you can't understand anything up to this from figure one onwards. Okay, up to this, from the figure one, you can't understand what is the problem, what we have to find out. Because of the notes, based on the notes only, I take the snapshot and put in the PPT and explaining it. So we reverse back to the problem one, first problem. Problem one. From the figure one, can start once again. So we start once again first from the problem figure one.
Can't hear you, sir.
Okay, now you can able to hear me.
No, sir.
Okay, can you able to see the slide? At least you can able to see the slide figure one.
Yes, sir. Yes, sir.
Your voice is not clear.
See, you can able to understand or not this is from one. What is the problem? What we have to solve this problem?
ಇಲ್ಲಿ He left the meeting.
रिकॉर्ड हो रहा है
Who
अभी।
left the meeting?
निकल गया, विनोद निकल गया।
लेकिन अभी भी रिकॉर्ड हो रहा है। अब अभिषेक क्या वे
विनोद बिन आया है भाई, ओडी रह गया।
सर कहाँ गए?
छोड़ भी को
सर स्क्रीन लेके निकल गया वो।
अबे सब लोग छोड़ दोगे तो सारे चले
भाई।
गए। टाइम हो गया।
Time up.
हो गया।
टाइम अब सब छोड़ दो।
निकलते हैं हम भी।
छोड़ दो भाई, छोड़ दो।
Finish off होते
फिर रिकॉर्डिंग ऑफ कर दो कोई।
रिकॉर्डिंग शायद सर ही ऑफ कर सकते।
नहीं, स्टॉप रिकॉर्डिंग का ऑप्शन दिख रहा है।
दिख रहा है तो ऑफ करना।
पक्का होता।
भाई कुछ समझ में नहीं आ रहा था, विनोद लिख दिया मैंने।
वही रेडी